Right, so what is Hbase? It's a NoSQL database, it's columnar and it's key value based, right? Yes, we had discussed the way we can install Hbase. You are working with a sudo node, and we can also call it as sudo distributed node. Why distributed? Because if you want, you can add number of slaves to your machine. Okay, so this diagram is basically of sudo distributed mode, okay, where you have your master, and in your master itself we have to, or we need to add three more services, that is Zookeeper, Hmaster and Hregion server. Zookeeper is a coordination service. It establishes coordination amongst Hbase processes. Okay, if Zookeeper is down, then Hbase won't work. Then in slave nodes you can have, along with your data node and task tracker, you can have Hregion server as a slave. Okay, so this is how you can deploy. In this diagram, this is for fully distributed, a prod environment, production environment, where you have dedicated machines for your masters, and for slaves, again you have n number of slaves, and there you have installed Hregion server. If you have a requirement that if you need to have more Hregion servers, then you can independently install in individual machines where there is no data node or task tracker. That is also a possibility. Okay, but recommendation is that along with your data node and task tracker, you should have your Hregion server. Okay. Yes, so this is how we have Zookeeper server, we have Hmaster, and we have Hregion servers. So Zookeeper server is one who provides coordination service. And how does it provide? It basically provides this way, that if there is one Hregion server which is up and running, so there will be a ping or a heartbeat sent to Zookeeper server, and Zookeeper server will create a Z node for it. We discussed about Z nodes yesterday, right? So Z nodes will be created by Zookeeper, and once the Z node is created in Zookeeper, then Hbase master, that process will ping or send a heartbeat to the Zookeeper, and it will get to know that one Hregion server is up and running. Okay, so as soon as more Hregion servers are coming live, they will keep on sending heartbeats to the Zookeeper, and this will basically make Hmaster aware that how many region servers are running, and accordingly it can plan to share the loads of regions. Regions are nothing but your tables, or basically a table is organized into one or more regions. Okay, and these regions are handled by Hregion servers. Okay, and Hmaster has got this responsibility to allocate the regions to particular region server. Okay, so when Hmaster is aware that how many region servers are there, accordingly equally it will share the load of the regions to the region servers. If some region server is down, in that case Hmaster will decide some other region server, some other in the sense that is in some other machine, to take care of the regions present in that particular machine. Okay, so this is a possibility that if the local region server is not up and running, or there is no region server service there, then basically Hmaster has that authority to basically allow or allocate any other region server for particular region servers to be handled remotely. Okay, for Hmaster also we have a concept of high availability. So you can remember this word, high availability, which means that if one of your Hmaster gets failed, then there should be a standby which should get up and running. This can be configured again with the help of Zookeeper only. So Zookeeper here plays an important role in case of Hbase master high availability, also in case of name nodes, also in case of job trackers, for preparing them for high availability. Okay, so those things we will discuss. About Hadoop 2 we will discuss those things. Okay, this is about Hmaster. Then this is a Zookeeper ensemble. I told you that Zookeeper ensemble can have 1 Zookeeper server, 3 Zookeeper server, 5, that is in odd numbers we can have, because of the election process which happens amongst them. So odd number will always give us an opportunity not to have a tie. Okay, not giving equal votes to a single or to two basically Zookeeper servers. Okay, then all your region servers, there you can see we have a table called as root, then we have a table called as meta, then we have a table called as T1, and T1 has got a region called as R1. Okay, so here whenever a client wants to fetch something, at that point of time the first request goes to the Zookeeper. Okay, remember this thing, because Zookeeper knows the state of each machine. So first, as soon as a query is passed, so that query starts contacting Zookeeper first. Why Zookeeper? Because a Zookeeper knows the location of root table. Okay, yesterday I told you that root table contains location of your meta table contains location of your user tables. Okay, but root table's entry is there in the Zookeeper. In some Z node there is an entry for root table. So whenever you fire a query or client fires a query, that query initially for the first time connects with the Zookeeper. Why? To get the root table location. So once the root table location is fetched, it will go to that particular machine. Machine means where a region server is running, and there it will identify that in which meta table. Okay, or basically what are the locations of meta table, and where it can go and search for its table, because in the query we have just put an entry of a table. Okay, yesterday we saw scan T1, so we are just passing a name of a table. We are not passing root table, we are not passing name of meta table, we are not passing that, because we even at the user level or at the developer level, we are not aware that in which region that particular entry is getting stored. Yes, so basically query will start parsing the root table, and from them parsing the meta tables. There may be one or more meta tables, it will parse that, and in the meta tables it will see that whether the entry of the table in the query is there or not. So if the entry is there, then in that case it will see that whether it is fetching the whole of the table, or whether the query is fetching some region, like some of the rows of the table. Okay, so accordingly what will happen, it will check that if all the regions are to be displayed or a specific region has to be selected, then that particular that query will be hit on that particular data node or region server, and there basically from there data will be fetched. Okay, so this is how the whole flow happens. Client request the Zookeeper gives location of your root table gives location of your meta table gives location of your table, and from there only, if you want a particular region, you can get from meta table itself. Okay, so this is how the whole query runs for the first time. But after first time you have run your query, second time if you are running the same query or similar query, then it will not again go back to the Zookeeper server and root, because that whole location, whole path has been saved by that particular client. So from where you are running the query, that plan will get saved, okay, for that particular session. So this time, first time you will have to basically traverse all the paths. Next time you can directly go for that particular tables region server. If you are querying some new region server, in that case some new table, in that case it may happen the whole path may have to be traversed. Are you getting this? So the path known once will not be traversed again via Zookeeper. Directly that query will fire that particular region server. Okay, so I explained these things. We have two types of system tables, root and meta. Even root is a meta table only, because that is table that is a table which contains information of user tables. Okay, so they are meta tables. And then we have user tables. User tables can be divided into regions. Regions are horizontal partitions of user tables, right? We discussed yesterday. Yes, so regions can be put into a single machine, or regions can be put onto multiple machines. This is a decision of basically your Hmaster, and there is a Hbase client library which actually interacts with your HDFS. So that client library takes up your, we discussed memstore flusher, the data is flushed from Hbase and that goes in HDFS in the form of H file. Yes, okay, so Hbase client is there. That's a library that helps to basically put up the data in the HDFS. So while discussing with the name node, they decide that where should be the data stored, because ultimate authority is with the name node. Name node decides that where the data will actually go. Okay, fine. We discussed that in Hbase there is no concept of normalization. It is all denormalized tables. Okay, so if we compare RDBMS tables and Hbase tables, so all RDBMS tables in a database are combined or clubbed together into a single table here, and the table name of RDBMS table becomes a column family here. Okay, so that way we can understand that whole of the table names will be a column family of a single table in Hbase. Okay, so we will have a single table for any application. Okay, so here we don't have a concept that we will create a database and in that database we will have a lot of tables. No, there is only one table that will be a kind of master table for you, where all your tables which you can think of in RDBMS, they will get combined here. Okay, this is how. So you can see that row ID is the key which acts as primary key. Okay, so which is analogous to primary key, not exactly primary key, but it is analogous to primary key, because when we are searching, when we are scanning, so while scanning yesterday we had seen, we just type scan and t1 table name. Okay, so it fetches the data. But if you want to basically query, like here we don't have where clauses, here we don't have group by clauses, we don't have as such clauses. Okay, so if you want to fetch data with the help of a row ID, then basically you can put across like your table name and then your row ID. So for that particular row ID only your data will be fetched. Okay, we will see that in the queries. Okay, so there is a very limited query set for Hbase. It's not very rich as we have SQL, or even Hive has got quite good query set. Okay, in Hive also you can almost perform most common operations which are there in Hive, but here very limited query set is there. Okay, you just need to see the syntax, that how basically query has to be done. So internally it applies your clauses. Okay, internally you need not to apply externally the clauses. That we will see in the practical part. So normalization we discussed yesterday, discussed in the sense just touched upon, and this is the flow how basically Hbase data is written in the SDFS. Okay, so client fires a query to, so for retrieval I told you, for retrieval how it happens, via Zookeeper, then root table. Okay, and now if you want to insert something, then how will it happen? It will basically fire a query. After firing the query, that will go to the log. Okay, that log is called as hlog or write ahead log, right? Okay, val or hlog. Then basically parallelly that data will get stored in the memstore as well. So memstore is a temporary memory. Okay, which will flush once memstore is full in the sense 64 MB is there in the memstore, it will get automatically flushed. If it is not 64 MB, then what is the second option? Another? No, if it is not 64 MB, then what will happen? How will it get flushed? Manually. We can manually flush it. Or basically if the data is there more than 5 MB and if you are shutting down the services, then also it will get flushed. If the data is not more than 5 MB and you are shutting down the cluster, then will you lose your data? Sorry? Yes, so because your data, your whole query is there in the val, so you will not lose your data in that case also. Okay, and yesterday we saw that when we are inserting something, it is not directly going in the SDFS. We had to flush it. Okay, so that proves that yes, it requires 64 MB of data to be there in order to be flushed in the memory. Okay, flushed in the SDFS. Okay, fine. So memstore flusher will run when 64 MB data is present. Actual H file will be created in SDFS via Hbase client, and memstore is flushed clean to receive new data. So once the data is written in the SDFS, then that temporary storage will be empty now, will be cleaned up. Why? Because if you have certain more number of rows to be stored, so it will be ready to accept more number of rows, records. Okay, so this is how insertion happens in Hbase. I also told you table is organized into regions, right? And a table has got multiple column families. Okay, a region is nothing but a horizontal partition of a table. So all your column families will be present in region 1 as well as your region 2, because it is a horizontal partition. So remember this thing, right? So if we have a column 1, C1, C2, C3, So if I divide it from, okay, these two rows I make a one region, those two rows I make another region. So I have all the columns present, right? It will not happen some columns are missing. So remember this thing. Okay, so every region will have all the column families, and column families will, again, they have their own columns, okay, and they will differ like some may have 1, some may have 10, some may have hundreds. Okay, it depends on the column family, how much information do we need to insert. Okay, yes. So this diagram depicts the same thing. We have a table and we have a region object. So two regions are there based upon the size, and every region, each region has got three column families. All the column families are present, and for a particular column family there is a store allocated. Store is nothing but a virtual memory, what we were discussing about mem store. Okay, so a store is allocated. So that store will basically, the important thing is, one is mem store, another is a logical unit of file, that is store file. Okay, that's not a physical file. So that basically points to or maps to the H files which are actually stored in the SDFS. Okay, so store will have your temporary storage, that is mem store, and another thing will be store files. Okay, and these store files will be pointing to the actual physical files stored in the SDFS. Okay, right. So I told you that H file may be one or more, because if you are flushing out your data and that is very small size. So yesterday also we saw that there were two files created and they were in KBs. Okay, so ideally the data should be in MBs. Okay, and that should be in 64 MB in this cluster which we have set up. Okay, so one store file of Hbase, okay, because I had only one column family. Okay, so there was only one store file, so that will point to two H files now. Okay, once they are combined, so store file will point to only one H file. Okay, so store file is just a logical entity with store that actually maps with the H files present in the, so that will help you in scanning. Okay, internally in scanning it maps to that, so those data from those files will be fetched. Okay, right. Then I spoke about compactions, right? So there is a compaction process, and this compaction process is organized into two parts. One is major compaction and another is minor compaction. Minor compaction is whenever you are, let's say yesterday I flushed two files and they were having very small size. Okay, so those two files will get merged and a single file will get produced. This is called as minor compaction. Okay, and in major expansion, what will happen, even with the new files, older files will also get considered, and whatever, like there will be a new file created. Okay, merged file will be created, and all the previous files which are of small size, they will get deleted, because we don't want them now, because we have a new file, okay, where all the merged data is present, right? So all those will get deleted. So this, when this thing happens, this is called as major compaction. Okay, right. So two types of compaction. This is minor compaction example. Newer files are merged and a single file is created, and in this example, newer and the dark red, that is older file, so all that will get basically merged. So if all that will get merged, that is called as major compaction. Okay, so this is all about Hbase, which we discussed yesterday, and now let us go for writing certain queries on Hbase.